Hello everyone, this is Amit, chemistry faculty. Today, the topic we will be dealing with is limiting reagent, right? Now, before dealing with limiting reagent, will have to know about the reaction. For showing any reaction, we use equations, right? Now, equations can be of two types: unbalanced equation and balanced equation. Okay, and in any equation there is two part. One is reactant and another is product. So in more concept we use balanced chemical equations, right? Before knowing about limiting reagent, we should know when we should apply the concept of limiting reagent. While dealing with questions, if mass of both or more than two reactants are given, then definitely we'll have to apply concept of limiting reagent. Now, before dealing with questions, let's understand this thing. Just consider there are two friends, right? One is good-hearted, and there are two friends. One is a good family. We can say that it is he belongs to a good family, and others does not belong to that good family, but is also okay. Then that decide that we'll go to fair and will spend money. And the one who was good enough said, I'll spend twice what we'll be spending, right? So just consider the scenario that there is a reaction A plus 2, B is giving C. Now, just consider that this friend has 80 rupees and this friend has 50 rupees. Okay. Now, what happens? This friend has said that I'll spend twice what you will be spending. Okay. So friend spends 20 rupees. This friend spends 10 rupees. Okay. Now again he spends 20, means total he spends 40. He spends 20, right? Now again 20 further, he spends total 60 and he spends total 30. Okay. Now again he spends total 80 and he spends total 40 rupees. After spending also, he has been left with 10 rupees. Okay, he has been left with 10 rupees. Now, what is the factor which is determining that they will be at the fair? The rupees of this friend, right? When the rupees of this friend ends, their fare also ends. Okay, right? Now, what happens? Now, who determines this? So, this is the thing which is known as limiting reagent, which is determining how many, what we will be doing, right? Yeah, in chemical language, we can say that the reagent will determines the amount of product formed. Now, after reaction, the reagent which is left is known as excess reagent. Is known as excess reagent. Okay. Now there is basic misconception. Many people think that limiting reagent is the thing which is present in less amount. No, it is not true. The limiting reagent is which is consumed in the reaction and which determines the amount of product formed. Okay. Now we'll deal with some questions like. First of all, we'll see simple question when to apply and when not to apply. Like if question is asked, what is the mass of ammonia formed by 56 gram nitrogen, right? Now, before dealing with this, we'll have to write equation for this reaction. And what is the equation for this reaction? It is N2 plus 3H2 is giving twice NH3. Okay. What is this reaction is saying us? That 1 mole of N2 is reacting with 3 mole of H2 and 2 mole of ammonia is formed, right? Again, in mass language, you can say that 20 gram of nitrogen is reacting with 6 gram of hydrogen and 34 gram of ammonia is formed. Generally, I suggest to approach these questions by mole analysis, because once we get mole, we can get mass also, we can get volume at STP also. Then it's preferable to solve these questions by mole approach. Now, what we can say, first of all, we'll have to find the amount of moles present in 56 gram of nitrogen. Then moles of N2 in 56 will be what? 56 divided by 28. You might be knowing molecular mass of N2, right? It will be 2. Now what we will say, that 1 mole nitrogen is giving 2 mole ammonia, right? Then what? Then 2 mole of N2 will be giving 2 into 2, 4 moles of ammonia. Now we have calculated moles of ammonia, then we can calculate mass also, right? Now see what is the difference and when to apply limiting reason. Same question, I am framing like this. What is the amount of ammonia formed by, what is the amount of ammonia formed by 14 gram nitrogen and 4 gram hydrogen. Okay. Now, what is the difference in this question? Here only mass of N2 was given and mass of ammonia was asked. In this, a mass of N2 is also given and mass of H2 is also given. Then in this, we will have to determine limiting reagent, the reagent which will be determining the amount of product formed. Now what we'll write? Again, reaction. We'll have always to write balanced chemical equation for any reaction in mole concept. Okay. There's other concept, equivalent concept, in which most of the questions are approached by without balancing equation. But while approaching with mole concept, we'll have always to balance the chemical equation, right? Now N2 plus 3H2 will be giving what? Twice NH3. This is reaction which you will have to always write. Now we will say mass of nitrogen given is what? 14 gram and mass of hydrogen given is 4 gram, right? Now again we will find its mole. Again we will find its mole. Mole will be 1 by 14 by 28 and its mole will be 4 by 2, right? Now for LR we'll have to divide mole by its stoichiometric coefficient. Then what will be its mole? What is its mole? Mole is 1 by 2 and its mole is 2. Now LR, for LR we'll have to divide it by 1 by 2 into 1 and its stoichiometric coefficient is 2 by 3. Then this is LR. Maybe this is a bit complicated. First let's see with simple equation. Like there is equation 2a plus 3b is giving 4c and moles is given, its mole is given, let's consider it's given 6 mole and its mole is given 8 mole, right? Its mole is also given 6 mole, right? 6 mole. Then first of all, how to determine LR? For determining LR, we'll have to divide this moles by its stoichiometric coefficient. Like its stoichiometric coefficient is 6 and it will be divided by 2 and its stoichiometric coefficient is 3. 6 will be divided by 3. We'll get what? Here we'll get 3 and here we'll get 2. Then which is less in amount? B is less in amount. Then in this reaction, B is what? LR. B is what? LR. Now again, second question, we can take anything. 3A plus 4B is giving C. Okay, now and moles given are let's consider here 8 moles are given and here 6 moles are given. So directly by seeing moles we cannot say that B is LR. we'll have to first divide moles by its stoichiometric coefficient. Okay, then what will be L for LR? We'll be dividing it by its stoichiometric coefficient. Then it will be what? 8 by 3, and this will be 6 by 4. The reagent which is less in number will be considered as LR. Then 8 by 3 and 6 by 4. 8 by 3 will be something 2 point something, right? And this will be 1.5. This will be 1.5 and this will be 2 point something. No doubt this is lesser in number, hence in this equation it is LR, right? So while dealing with questions of LR, we'll have to first find moles and then divide it by its stoichiometric coefficient, and then which is less in amount, that will be considered as limiting reagent. Now let's just see the question which I dealt with. What was the mass given? Mass was given 14 gram and mass of hydrogen was given 4 gram, right? So what will be moles? Its mole will be 1 by 2 and its mole will be 2, right? These are the moles. And again then we'll divide it by its stoichiometric coefficient. What is its stoichiometric coefficient? 1. So what will be this? 1 by 2 into 1, and this will be, what is the stoichiometric coefficient of hydrogen? 3. So 1 by 2 will be divided by 1 and 2 will be divided by 3. Again, which is lesser amount? This will be 0.5 and this will be to something 0.66, right? So this is lesser in amount. Then in this reaction, N2 is what? LR, right? This is the process how we find the LR. Okay. First we just focus on finding LR, then we'll proceed further for how to calculate the amount of ammonia found or whatever it is. Okay. Now let's see one question. Okay. Calculate the amount of KClO3 formed by 74.5 gram of KCl and 32 gram of O2. Okay. Then again we'll have to first write the reaction. And what is this reaction? Twice KCl plus 3O2 will be giving what? 2 KClO3. Okay. Now mass given of KCl is 74.5 and mass given of oxygen is 32. Okay. Now second process is we'll calculate mole. Then it will be 74.5 divided by 74.5. Molecular mass of KCl is 74.5. We calculate it and we know how to calculate it earlier, okay, right? And moles of this will be 32 divided by 32. This will be 1 and this will also be 1. Now at this instant we cannot determine the LR. Again for LR we'll have to do what? We'll have to divide it by its stoichiometric coefficient and this by its stoichiometric coefficient. Again, which is less in number will be considered as LR. So which is less in number? O2 is less in number. Then we'll say that O2 is what? LR. That O2 is what? LR. Clear? Now, how we'll calculate the mass, amount of KClO3 form? Now in any reaction, what this reaction is telling that 2 moles of KCl is reacting with 3 moles of O2 and we are getting 2 moles of KClO3, right? Then first of all we'll have to deal with this reaction, this equation only. So which is LR? O2. Now what we'll say that 3 mole of O2 is giving 2 mole of KClO3. Then what 1 mole of O2 will be giving 2 by 3 moles of KClO3, right? But we have to calculate the mass. Then we know mole is equal to mass by molecular mass, right? And what is moles? 2 by 3 is equal to X. What will be molecular mass of KClO3? KClO3 molecular mass will be potassium, atomic mass of potassium is 39 and atomic mass of chlorine is 35.5 and atomic mass of oxygen is 16 and it's 3 number, then 3. Total after calculation we get what? 122.5. Okay, then what will be mass? It will be 2 by 3 into 122.5, right? Which can be, what will be this? 122.5 will be 3 4s are 3. It will be something around, it's 40, 43 are 120, right? 43 are 120, 41 3s are 123. It is little bit less than 123. Okay, it's about 4182 gram, not 82, little less than 82 gram, right? So this is the process how we deal with the questions of LR. Okay, thank you.